Can't stop, won't stop moving.
Don't speak the language.
Music.
Don't need explaining.
I know that in the morning now, it's gonna be alright.
Quality control is a process that measures output relative to a standard and takes corrective action when output does not meet standards. If the results are acceptable, no further action is required. Unacceptable results call for corrective action. The purpose of quality control is to assure that processes are performing in an acceptable manner. Companies accomplish this by monitoring process output using statistical techniques. Every process generates output that exhibits random variability. That is natural and cannot be corrected. However, if there are non-random variations in process output, that can be corrected. Quality control tools are used to decide when corrective action is needed. Quality assurance that relies primarily on inspection of lots, batches, of previously produced items is referred to as acceptance sampling. The best companies emphasize designing quality into the process, thereby greatly reducing the need for inspection or control efforts. As you might expect, different business organizations are in different stages of this evolutionary process. Some rely heavily on inspection. However, inspection alone is generally not sufficient to achieve a reasonable level of quality. Many occupy a middle ground that involves some inspection and a great deal of process control. This is an illustration of approaches to quality assurance from the least progressive into the most progressive.
How are you?
Doing all right.
So Matt, how do you make sure bad things don't happen to good projects?
Well, Bob, we do that by assuming one of two roles on a construction project. Quality assurance, or QA, where we represent the owner and we monitor the materials for compliance with the International Building Code and local municipalities. And quality control, where we represent the contractor and we monitor their materials during the construction process.
Can't you do both on a project?
No, we can't. That would actually be a conflict of interest. But we do start early. If we've performed the geotechnical engineering on a project, it really does help us build efficiencies later on in the project. On the materials testing quality control side for the contractor, even though our services are normally less than 1% of a construction budget, we can really have a significant impact on the budget and safety towards the end of a project.
How so?
Say you're building a multi-story building and you don't catch a batch of concrete that's bad early on in the first floor. To go back after the fact would cost a huge amount of money to repair or replace that, considering the load that's already on the building.
Wow, that happens?
It does, and it takes a lot of early and constant monitoring on the front end of that project, especially considering it could be a life safety issue for whoever inhabits that building once the project's complete.
Matt, how do you make sure then that doesn't happen?
Well, we stay fully engaged as part of the quality assurance, quality control process review. We will provide recommendations, we will look at the plans, we will assist the owner or the contractor in coming up with the right steps to make sure that the monitoring of materials is done.
So Matt, you're kind of the owner's technical expert.
That's right. So we complement the work of the designers and the contractors, and given the expertise that Terracon has in geotechnical, environmental investigations, we can provide quality on all aspects of the materials testing process. And we also provide special inspections.
And those are?
In every municipality, there's certain localized inspection requirements. Given the number of offices Terracon has across the country, we're very well positioned and we're knowledgeable in those local markets to provide those inspections for our clients.
That must take a lot of time.
No, we can notify the contractor or the client within 24 hours of a deficiency because we want them working on a corrective action immediately. We don't want the design team waiting around for a corrective action report from us.
You're doing constant on-site monitoring?
We are, and we can even go to the fabrication shops ahead of time so we can save even more time and money by finding problems before the product's even shipped to the job site.
How can you do this better than all the other companies?
We approach the project as if we're a full partner. We have a unique viewpoint, that of the designer, contractor, and owner, and because of that extensive experience, we bring in a total understanding of the entire construction process. So this may be just one of a handful of projects that our clients may do this year, but we do hundreds, so we've seen every problem that can come up.
Thanks to Terracon, this project won't turn into another leaning tower.
Absolutely not.
Statistical process control is simply monitoring the consistency and the repeatability of a specific process. It's not a complicated thing. It's really quite a simple approach to understanding what is the reliability of my process. An example of that might be torquing a bolt. In torquing a bolt, there are a lot of variables that can go wrong to cause an over torque or an under torque situation. In that example, if we apply statistics and understand the actual capability of the process, we can predict the failure rate within that process and make running adjustments so that we don't have actual problems occur.
Another example of Honda's use of data collection to understand its processes is the door closing speed test. This test measures how fast a door needs to be moving in order to close, but without slamming it.
So today we're looking at the business process capabilities within an organization to allow them to get successful change, successful improvement, and process management. These are the key capabilities that you would require in your business to achieve proper business process management.
A typical day on the job is early mornings, an hour before the first load goes out. Grab some moistures, which are the stone and sand, and we're trying to see how much water is within that aggregate. Then we start looking through all the orders, making sure that the orders are set up to the way that the mix should be. Then the trucks come. Then now it's time for the actual testing. There's 3 major factors you're looking for in a test, which is your air test, your slump test, which is the workability of the concrete, and your temperature, which determines how hot that concrete gets. We run gradations once a week to make sure they meet certain specifications required by IDOT or CDOT. We also have tests as far as in specimen cylinder tests, where we make molds based on the concrete that we tested for the day. We'll strip them the next morning and we'll cure them in tanks until it's time for them to be broken, and showing compression strength on those tests to make sure they meet those specifications required by those jobs. One of our biggest challenges in quality control would be environmental changes. I mean, you can't predict for the weather, you can't predict for temperature, and you can't predict what concrete will do at times. So the challenge for me is just kind of getting feedback from drivers or feedback from QC in the field to kind of let me know what's happening to the concrete from when it left my hands to when it got on site, so I know how to make those appropriate and proper adjustments.